Hello and welcome to this section of the MATLAB tutor. Here we're going to continue working with calculus, and in specific we're going to learn how to do an integration in calculus with MATLAB. So what we'll need to do, much like differentiation, is we will define a function and then we'll learn how to use MATLAB to take the integral of it. So in order to do that, first let's go ahead and define a function. So you can use any label you like, but for now let's just use f, and let's create a function using the inline command. That's what we were doing in the previous sections. And just for the sake of making it easy, let's pick something that everybody can integrate, or at least wrap their brain around pretty easily. So let's do x squared plus 2 times x as our function. And of course, when you define an inline function, you have to tell it what the independent variable is. So this is very much like what we were doing in the last section. So now we have an inline function, x squared plus 2 times x. All right, now at this point, this function behaves like any other function we've created. We can pass arguments to it and we can get numbers out. That's sort of the point of functions, right? So let me clear the screen and put f back on the screen. That's what our function's defined as. Now in order to do the integration, just like we did in the last section with differentiation, we need to make the x variable that's in this expression, we need to make it symbolic, because we can still do the functional calculations like plugging in numbers like we were just doing, but if we try to pass this and integrate it now, MATLAB's going to give you an error. In fact, let me just show you what happens. The command to integrate a function is to go int, that stands for integration, f of x, and you can say comma x, so which means dx, right? So f of x dx. And it's going to try to symbolically integrate that. So if we hit enter, undefined variable x. The reason is because when we create these inline functions, even though we have x here, MATLAB is just kind of using it as a dummy variable to calculate the values when you pass numbers to f of x. Notice there's no x over here at all. So what we need to do is define x to be a symbolic variable so that MATLAB can then use the symbolic toolbox to work with it. So all you have to do is go sims x. Now you'll notice over here x is a symbolic variable, and now when we manipulate f of x in terms of these calculus functions, MATLAB will know that it's a symbol and it can use the symbolic toolbox to work with it. So let me go up space till I get to the last command I entered, integral of f of x dx. Go ahead and hit enter. MATLAB computes the answer, and if that doesn't look nice for you, you can always pretty it up by passing the last answer to it like this. And so you'll see the answer is given here, x squared, x plus 3 over 3. So MATLAB can pretty much integrate any function symbolically that's possible to integrate symbolically. If it's possible to do a simplification or a substitution or something to get a symbolic closed form answer, MATLAB's going to be able to do that. So let me show you one thing though. I just told you that the command int is the integral function, and I did f of x comma dx. Now for integration, the comma x there is actually optional. So it's nice to put it there so that you tell explicitly I'm integrating over dx, but MATLAB's smart enough to know that if you're just taking the integral of f of x and there's only one function, one variable x in your function, then it's going to integrate over dx. So you go ahead and hit the answer and you get the same thing. So basically when you're doing integration, you don't really need to specify dx. It's an optional thing. You just do int f of x. So let's clear the screen and let's do this a couple more times to give you the hang of it. Let's say the new function I have is g, and I'm going to create an inline function, and I'm going to call it, let's do something trigonometric. Let's say sine of x plus cosine of x squared. So that's kind of complicated. That would be a little difficult to think about. At least you'd have to think about how to simplify that and so on. And x is our independent variable. So let's go ahead and define the function like that. Inline functions created. Now again, x is already defined to be a symbol variable. It's already a symbol variable from before, so we can go ahead and just leave that alone because it's already done for us. So when we do int g of x, we're going to take the integral of the g of x function. It's going to assume we mean over dx, and it's going to give us the answer. And let's see what we have. X over 2 plus sine of 2x over 4 minus cosine x. And you can pretty that up by just using the pretty function, and there you go. That's the final answer. So that's a difficult integral, right? You see MATLAB's very quick about doing it. Let's do one more really quickly. Let's do JSON equals inline. Let's do something with an exponential. E to the power of x squared. Actually, let's do a different variable. T squared, right? E to the power of t squared minus t raised to the fourth power. Something a little bit weird. All right, and let's do that the independent variable is t. So there's my function, e to the power of t squared minus t to the fourth power. But notice our independent variable is t, so if we want to integrate over it, we need to declare t as a symbolic variable. So we declare it as symbolic, t pops up over here in the symbolic workspace. We have everything defined, and we should be able to integrate JSON as a function of t. And we don't have to put comma t. We put comma t here if we want, but MATLAB knows that since there's only one variable in this expression, we integrate it, it's going to do our best to give the answer. Now notice that this function is quite complicated, so when it actually does the integration of answer, then it's giving the answer for us in terms of one of these specialized functions that you find in math that come up with these complicated integrals. So it's done the work for us. It gives us the answer in terms of another math function that is a little bit beyond the scope of this lesson, but it does the integration for us perfectly. Now let me go ahead and clear the screen. So far we have done symbolic integration, what we call indefinite integration, where we're just trying to find the function that's the antiderivative of whatever it is we're talking about. But many times you want to do a definite integral. So let's just go back and put f on the screen. This is the function f that we were using before. So the way we did it a minute ago is we just did f of x and we closed it off like that, and it calculated the indefinite integral. But if you go in here and you inside of this integration function and you tell it I want to integrate f of x from 1 to 4, then it will calculate the integral and then it will evaluate it from a to b. So this is the lower bound, this is the upper bound. So what we should expect is a number. And we get a number, 36. So when you do integration, whether it's definite integration or indefinite integration, it doesn't matter. You use the same function. It's just that you have to pass at the endpoint. So it's very, very simple. Let's go back and look at our g function. So our g function is given like this. This is what we were working with before. And we can integrate the g function, g of x. And we could say from -4 to 10 if we like. So lower bound, upper bound. And MATLAB will think for a second. Now notice, in this case, it's trying to always, since we're dealing with a symbolic math toolbox, which is what we're always doing in these calculations, it's always going to try to keep the number exact, right? So it's giving us an exact answer. Cosine of 4 minus cosine of 10 plus all this stuff. It's all in terms of pure sines and cosines because it's always trying to keep it exact. If you need an actual decimal, you just do double answer, take the last answer, put it through the double function, and you get 7.66. So that's how you do integration in MATLAB. Basically, you need to define your function, and you need to make sure and take your independent variable, in this case it's x, and treat it as a symbol, so declare it as a symbol. In the other example we did where we did a function of t, we had to go ahead and put t as a symbol. And once you have it, your independent variable as a symbol, and you've defined your function in terms of defining it as an inline function, then you just pass it to this built-in MATLAB function called int, integration, and then if you just pass it without any other arguments over here, then you get the symbolic indefinite integral, and if you pass it the upper and lower bounds, then you get the definite integral. So it's very cool, and MATLAB can handle pretty much anything. So definitely go in there, define your functions, play around with it, make sure that you can do indefinite plus definite integration, because constantly over and over again when you're doing programs and solving real problems, you're generally going to be calculating something, and a lot of times that's going to involve an integration or an integral. So make sure you understand how to do this, practice it, and then go on with me to the next section where we will continue learning how to do core calculations in calculus with MATLAB.